So today I thought I'd make a quick video to talk about the mechanics and perhaps the energy considerations for a cyclist going uphill. Welcome along once again, physics fans. So what forces are acting on this cyclist as she goes up the hill? Well, there's only really two, and the first one is the one that everyone knows, that's her weight, which is of course acting straight downwards towards the centre of the earth. And the other force is going to be what has various names now. You probably know it as support force. I also know it as normal reaction. So many and varied. So we'll call it the support force. That, of course, is by definition at a right angle to the surface, like so. If we ignore air resistance and if we ignore friction, which we always do, don't we, in physics, then that means that those are the only two forces acting on her. So why, if she stopped pedalling, then would she go downhill? Why would she head off nicely down the slope like that? Well, there must be a force acting down there, mustn't there? So let's see if we can see where that's coming from. Well, it can't be from the support force because, as you can see, there's a right angle there, which means there's no component of the support force down the slope. So the only other possibility is that it must be from her weight. So let's add the components of the mg, or the weight, then. So we have one that would be going like this, and that one there would be equal and opposite to the support force there. And the other component will be that little green one at the bottom. Now, of course, we can pick up these vectors and move them around, and obviously that little green one is heading down the slope. So what we might call the force down the slope is the component of the weight. Now, what's the triangle that we've got going on here? Well, we have our mg, like this, that's going to be our hypotenuse. We then have that one there, and we have the one that we're interested in, which is fs. That angle there is 30, and we know the length here, the hypotenuse, is mg. Therefore, we can say that fs is equal to mg times sine of 30. You could also, of course, have the cosine of 60 if you wanted to. The next part of the question might ask something like, what is her mass, given that you have a power, or she's generating a power of 300 watts and travelling uphill at steady speed of 2 meters per second? Well, this is quite straightforward, because if we know that the force downwards there is Fs, which we just worked out, we can use the formula. The power developed is force times velocity. Really useful, not very often spoken about formula. So the power there we know is 300, and we know the force is equal to mg sine 30, and all that lot is going to be times by the velocity, which of course is 2. Remember, we are after mass, so we rearrange to get mass on its own. So taking the other terms over one by one would be 300 divided by g divided by sine 30. Careful with the brackets now, I would put a bracket like that, times 2. And when you type that jolly lot into your calculator, you get 30.6 kilograms, where you probably can't justify that much accuracy, so let's just call it 31 kilograms. So although in the diagram the cyclist looks like an adult, she is in fact probably just a child, maybe 10 years old or something like that, because 30.1 kilograms is not very much, and this is always the joy of making up questions like this. Anyway, there you go. Well, I hope that was a little bit useful. Ta-ta!